10th Standard ICSE Math, Chapter 11, Geometric Progression. In AP, that is arithmetic progression of the previous chapter, we saw that in the series there was a common difference. Here we have a common ratio. For example, look at this term, these terms. It's a GP series because each term is triple of the previous term. So 6 upon 2 is 3, 18 upon 6 is 3, and 54 upon 18 is also 3. So what will be the next term? It would be 54 multiplied by 3. That is 162. So that's a geometric progression. Even here, we see that they have a common ratio. The general formula for a GP series is this. The nth term is given by a, that is the first term, multiplied by the common ratio raised to n minus 1, where n is a number of terms under consideration. So using this formula, we can now solve such sums. Exercise 11a. Cancellations, because they are easy. 11.1.1, question 2, question 5. These sums are in syllabus. You can even try it out, but to reduce your homework, I'm cancelling the same types of sums. 1.2, a series is given, a sequence is given, and they're asking us, is it GP or not? So we'll just check the ratio of second to 1 and third to second. And if the ratio is same, and even the fourth to third, and if the ratio is same, common ratio, then it is a GP. Notice that it is not necessary that the number should increase. They can decrease as well, and it can even alternate between positive and negative numbers. So 1.2, second term upon first term, on division I'm getting the common ratio as 3. And that is the case when I divide the third term to the second term or the fourth term to the third term. Since the common ratio is same, hence this sequence was a geometric progression. Remember that our population is increasing as a GP. It's doubling every few years. Whereas our food production and our resources production is not increasing as GP. That is increasing by AP, even with the modern technology. So I want you to pause and take a pledge that you would not contribute much to the population explosion much. Third one. Find the 7th term of the GP. So they've given 1, 2, 3, 4 terms, and they are saying it's in GP, so they will have a common ratio. They want the 7th term. So first of all, we'll write the data. The first term A is 1, and the common ratio will be the second term upon the first term. Even if you would have done it with the fourth term upon third term, you would have got the same answer, which is root 3. Now the general formula. Nth term is always A into R raised to n minus 1. They want the 7th term. That will be a r raised to 6. A's value we know, r's value we know. Root 3 into root 3 is 3. So root 3 into 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 root 3 will be 27. So that's your final answer. Now let's do the 6th sum. Find the nth term of the series. So they just want a general formula. The first term is 1 and the common ratio is 2. So the nth term will be a r n minus 1. A's and r's value we know. So we are left with this. This is the general formula for this particular sequence. Now the 8th sum. Find the 6th term of the series. 3 terms have been given. So same method. The first term is 4 and the common ratio is 2. So the nth term formula has to be written. Let's substitute. 6th term will be a into r raised to 5. A's value we know, r's value we know. Solving, we get 128. Now the 10th sum. Find the GP whose first term is 64 and next term is 32. So first 2 terms are given. If only we can find the third term. So there we have a GP. So we have the first term, we have the second term. Using these 2 terms, we can find the common ratio. And once we have the common ratio, we can find the third term as well, because the third term is nothing but the second term into the common ratio. So that is 16. So the GP is 64, 32, 16. Can you guess what will be the next number? Yes, it is 8. 12th sum. Find the next 2 terms of the series. So again, 4 terms have been given. They are alternating between plus and minus sign. And yes, there is no comma in between, but that doesn't change anything. The method remains same. A is equal to 2 and the second term is minus 6. So using this information, we can find the common ratio, which turns out to be minus 3. Now they want the fifth and the sixth term. So let's find the fifth term first. That will be 8 into r raised to 4. Yes, I'm writing it directly now. A's value we know, r's value we know. Solving, we get 162. Treat the sixth term in the similar fashion and we get minus 486 as the answer. So we form the next two terms. Either box the answers or write a final statement with the final answer. Now exercise 11b, first sum. Which term of this GP is minus 5 upon 72? The first three terms are given and we don't know at what position will you find minus 5 upon 72. Maybe the 10th term, maybe the 100th term. Let's find out. Formula will be same, no new formula here. A is minus 10, that's the first term of the series. We can find the common ratio by dividing the second term with the first term. Be careful with while solving this. Division becomes multiplication with the reciprocal. Minus sign will remain as it is. 5 ones are, 5 twos are. So the common ratio is minus 1 upon 2 root 3. Now we want the nth term. We don't know the value of n. We have to find that. But we do know that the nth term is given as minus 5 upon 72. Substitute the value of a and r. Now I just want the value of n out here. Send minus 10 on the other side. Minus sign will remain as it is, okay? But minus and minus will get cut. And 5 ones are, 5 twos are, so 2 goes down. So 1 upon 144. Now the best way to get the value of n is convert this into a power and make sure that the base is same. So I have to write 144 in terms of a power of 2 root 3. For that, let's do prime factorization. So I'm getting 4 2's and 2 3's. But notice that here we have root 3. So I can split this into 4 root 3. So it is 2 into 2 into 2 into 2 into root 3 into root 3 into root 3 into root 3. That's exactly what I wanted. I've got 4 2's and 4 root 3's. So the power of 4 will come into play. Also, I'm going to put a minus sign here. Because the power is 4, the minus sign will disappear anyway. So not a big deal. But this way, LHS and RHS will have the same bases. Only then can I compare the powers. So I've converted 1 upon 44 into minus 1 upon 2 root 3 raised to 4. If I multiply this 4 times, I will definitely get 1 upon 44. So n minus 1 is equal to 4. So n is equal to 5. So it is the fifth term. Third sum. The fourth and the sixth terms are given and find the GP. Alright. The fourth term is given, that is AR raised to 3 is 1 upon 18. Seventh term has been given, so AR raised to 6 value is given. Divide this by this. Yeah, bigger power upon smaller power is beneficial. So AA disappears, 3 and this is 3, so 3 remains. So R cube remains in the numerator. And divide these also, this divide by these, this, but multiply with the reciprocal, minus sign stays, we get this. So I want the value of R, so the cube goes to the RHS and becomes cube root. Minus sign will remain, and the answer is minus 1 upon 3. So now I know the value of R. So let's find the value of A. Let's substitute this into this equation, or this equation, but I prefer this. So copy this equation down, substitute the value of R, solve typically, and get the value of A, which comes out to be minus 3 upon 2. So that's the first term. And now find the second term, AR, and the third term, AR squared, and that's how you get the GP, alternating between negative and positive, but that's okay. Now the seventh sum. By the way, we are cancelling 6th and 10th sum simply because they are easy, but if you need more practice, then solve them as well. Seventh sum, second term is 6 and the fifth term is 9 times of the third term. Find the GP. And consider that each term is positive only, no negative values allowed. Okay, so I'm writing the data down. Second term is 6, means AR is equal to 6. Fifth term is 9 times the third term. So AR raised to 4 is equal to 9 times AR raised to 2, that is squared. A and A cancelled, R squared cancelled, only 2 remains in the power. R squared is equal to 9, R is equal to plus or minus 3, but let's ignore the negative number, let's be positive here. And now substitute this out here, we get the value of A as well. So I got the first term, and once I get the first term, the second term we already knew. And the third term is obviously the second term into R, which is 18. So 2, 6, 18 is the required GP. Now the eighth sum. The fourth term is given as 10. The seventh term is given as 80 and the last term is given as 2560. Find the first term, the common ratio, and the number of terms. So the fourth term is given. So fourth term is 10. So AR cube is equal to 10. Also, seventh term is given. So AR6 is equal to 80. So what do we do in such a case? We do a ratio, because that way A gets cancelled and we get the value of R, which is 2. Once we get that, then resubstitute this out here to get the value of A, which comes out to be 5 upon 4. So we got the common ratio and the first term. Now we have to find the number of terms such that the last term is this. If the last term is this, we'll use a normal formula. We know the value of A, we know the value of R. 4 goes up here, 5 goes down here. Now again, I'll have to convert this into some power of 2 because the bases should be same so that the powers can be equal. So do the prime factorization. You'll get 2 into 2 into 2 into 2 11 times, and then that becomes n minus 1 is equal to 11, so n is equal to 10. So there are 10 terms. The 10th term value will be 2560. Hi students, this is AJ sir. If you like this video, press the like button. If you would like to enroll for my online test series or online lectures, email me or message me on Instagram. Check the description for more information.